I just talked about it.
Oh, okay.
Do you need one? Yeah, it's on the pink. All right, so does everyone have yesterday's packet? You need one? All right, so everyone please turn to the page that says triangle similarity. Cool. So yesterday we learned about triangle congruence, right? How do you prove that two triangles are the exact same, right? So there was 4 ways you could do that. You could measure all the sides. You could measure 2 of the sides and 1 of the angles. You could measure 2 of the angles and 1 of the sides, right? If you did any of these 4 and you found that, right, those 3 parts are the same, that means the whole thing is the same, okay? So today what we're gonna do is a little bit similar, okay? We're gonna be working with similar triangles this time. So how do you prove that triangles are similar? So you don't have to prove that they're the exact same thing, you just have to prove that they're the same shape, okay? So for triangle similarity, we must use a scale factor to determine if the sides are similar, okay? So go ahead and write that down, right? We must use a scale factor to decide if they are similar, okay? The scale factor can be found by dividing the side lengths. Okay. And then when you do that, you find their ratio. Okay. Someone remind me, what is a ratio? Anyone know?
X to Y or A to B.
Yep.
2 would basically be the 1.
Yep. Yeah, exactly, right. So just like both of you said, right, it's comparing two numbers, like 5, 1, right? 4 to 2, 3 to 4, right? It's like you have 2 different numbers and you're trying to compare like how big they are compared to each other, right? So you can also write ratios as fractions. So for example, 1/5, right? That means something is 1/5 as big as the other, okay? So you'll see what we mean in a sec. So when we're looking at similar triangles, this time there's only 3 rules you can use. Okay? So there's angle, angle. So if you know there's 2 angles that are the same, that means the shape is the same, okay? Not the size, just the shape, okay? So angle, angle also includes AAS, SAA, ASA, right? Basically, if you know the two angles are the same, you don't even have to know that the sides are similar, right? As long as you know there's just two angles, that's fine. Okay? Next one is SAS, right? So if you know that two of the sides are similar, then you can find the angle and prove that it's similar. And of course, the last thing is, right, if all three sides are similar. Okay? Yeah, it's the pink one. Yep. Okay. So, looking at these examples, right? Everyone please turn page. So looking at number 3, okay? Number 3 is where we have to start looking at like how big are these triangles, okay? So let's say we have this small triangle, I'll color in red, and then we have this big triangle, okay, color in yellow. Right? How do we prove that these are the same shape? So first, we have a shared angle, right? So the red triangle has this angle. The yellow triangle also has this angle, right? So one of the angles is the same. We can put a little A just to show that, we already have an angle pair. Okay? So now, what we have to do is figure out, are these side lengths, do they make the same ratio? Okay. So what we're going to do is this. So the yellow triangle right here, this has a side length of 10. Okay. The red triangle down here has a side length of 6. So if we want to find their ratio, all you have to do is put it in a fraction. Okay? You're going to write 10 over 6. Okay? So go ahead and write that on your page. 10 over 6. Okay? That's going to equal something. Okay? So, does anyone have their calculator handy? What does this actually equal? 10 over 6. 1 point what? 1.4? 1.4. Is that right? 1.6? Okay. 6. 1.6. Okay. Double check just to make sure. Okay. So it's really 1.67, right? 1.67. I want to make sure we keep those decimals. Okay. So this is 1.67. Now we just have to check the other sides. Do they make the same ratio? Right? So here, the bigger side is 5. How big is the small side? 3. Good. Okay. So the other one is 3. Okay. So 5 over 3. What does that equal? Okay. Good. They both equal 1.67. Okay. So that means their scale factors are the same. Okay. This is 1.67. This is 1.67. Yeah. So that means it has two sides or two pairs of similar sides. Okay? So that means we have SAS. Okay? So this side is similar. This angle is similar. This side is similar. Okay? Side, angle, side. Okay? So that means this thing, or these two triangles, are the same shape. Okay? Any questions so far? Okay. Let's look at number 1 now. Okay, so number 1, we only have angles this time. Right? So obviously 87, 87, that's an angle pair. Right? So we already have one pair. Okay. Are there any other pairs that we know are the same? Jaden?
Wait, no.
Okay. So are there any other angle pairs? Like we know for sure these angles have to be the same. Let's go to Jaden first. So the top angle here, here, right? Yeah. Okay. So these two angles have to be the same. Okay. Why are they the same? Yeah, because they're opposites, right? And opposites are congruent. Okay. So that means we have another angle. Okay. AA. Okay. And if you know that two of the angles are the same, what does that mean? They are similar, right? Okay. So these are similar. Okay. If you have two angles that are pairs, they're similar. Okay. All right. So we've covered AA and SAS, right? Let's look at this one, number 2. Okay. So number 2, we have an angle pair. We have A. Okay. We have this side is 3, this side is 8. Okay, so if we were to find their ratio, it would be 8 over 3, which is like 2 point something. Right? Someone put in their calculator. Yeah, 2.67. Okay, so we have a side, right? That's similar, or at least we think so, right? But is there anything else that we can use? No. Right? If you look carefully, there's no other numbers, right? And there's no other angles, there's no opposites, no nothing, right? So there's nothing else we can work with here. So that means these two triangles, we cannot prove that they're similar, okay? So these two, you cannot prove them. They are not similar, okay? They might be similar, but we can't prove it, okay? That's the key here. So we're trying to prove that these are the same. Okay? All right. So looking at number 4, right? For number 4. So what I want everyone to do, figure out this angle and this angle, okay? So everyone take a minute to go ahead and figure out these two angles, right? Using what we know about triangles and geometry. And then we're going to decide, are these similar or not similar, okay? Calculator. Yep. All right, let's go to Stanley. So what are our two missing angles? Okay, so here we got 48. Here we got 42. Okay. So Stanley, are these triangles similar or not similar? They're not similar. Why are they not similar?
This one, the smaller one has 90.
Okay. And the bigger one doesn't? They are similar, right? Okay. So they are similar because look, right here, small triangle, right? 90, 42, 48. Here, big triangle, 90, 42, 48. Okay. So that means that they share all three angles, right? Like this 90 is the same for both of them. Okay? So yeah, these are similar, right? So you can prove with two angles they're the same. Okay? All right, now let's look at number 5. Okay? So number 5, we want to prove that they have the same scale factor. Okay? So here we have a shared angle, right? Like both triangles use this angle here. So we already have an A. Okay. Now we need to prove these sides have the same scale factor. Okay. So how am I going to find the scale factor? Not quite. Not 4 over 2. Not 2 over 4. Because this 2 is for this part, right? And this 3 is for this part. So remember right here, right? For this one, the whole thing was 5. And this one, the whole thing was 10. That's why we did 10 over 6, right? We did the big side divided by the small side. Here, right, the big side is actually how much? No, it's actually 6. Yeah, right, it's actually 6. You got to add them, right? So here you got to do 6 over, what's the small side, right? The small triangle. 4. Right? So if I highlight it in color, right, it'll be easy to see. So the big side is 6, and this one is 7.7. Right, that's the big triangle. Right. The small triangle, I'll do green. Right, the small triangle is, yeah, only 4 and 4.7. Okay. What's that? 3/2. You do, but you have to add them, right? Like this part is not the full triangle. That's why you're not using just 2. You got to add 2 first, then divide. Okay. So, what does 6/4 get us? 1.5. Okay. And then what was the other one again? 7.7 divided by 4.7. Okay. And what does that get us? Yeah, 1.64. Okay. So, are these similar? No. Okay. Let's go to Kiki. Why are they not similar? Exactly, right. If these were similar, the scale factors would be the same, right? If you divided them, then they would come out to the same number, but they don't. Okay, so that means for number 5, these triangles are not similar. Okay, so the diagram is misleading, right? It looks similar, but actually, if you were to draw this triangle the way it's supposed to look, it would really look like something like that, right? This side is a little bit too big. This side's a little bit too small, right? That's why it's not actually the same. Okay? All right, so let's all look at number 6. Okay, so for number 6, you have big triangle right here, and small triangle right there. Okay, so on your own, go ahead and find what are the scale factors for these sides. Okay, we already know that these angles are the same, so we already have that covered. Go ahead and find the ratios for these sides and see if they're the same. Okay, you can work with a partner if you want. What do you mean? So this time you don't. Well, try number 3. If you do number 3, you'll see why. Oh. What did
not these. I mean,
Okay, next. So are these similar? Yes. Did you do credit all these? You don't want to do use a part of the you want to do that. On the big triangle over. Here. All right. Let's go to Jacob. So for number, what was it, 6? So are these similar? Yes. Okay. So what is the proof?
13.5, 4.3, and same thing for 9 over 3.
All right. So when you divide it out, they both make 3. Okay. So what is which rule are we using? Which proof? So AA, SAS, SSS. It's not SSS because we didn't do the third one, right? Yeah, it would be SAS, right? So we had the 2 sides. Where is the angle? Yeah, right here, right? So these 2 angles are the same, okay? So SAS, good. All right, let's do one more practice. Let's do this one, number 8, okay? So number 8, go ahead and figure out, are these the same scale factor? So I'm gonna highlight the sides for you just to make it a little bit easier to see, okay? So you're gonna check for each of these colored pairs, right? Do they make the same scale factor, okay? Go ahead and write down those ratios and see what you get. Yep. So I highlighted here. With the blue sides. I'm gonna do this down, highlighted. Blue one. Big blue one. And violet. go to Maya. Are these similar or not similar? Yes, they are similar. So how do we know? How do we know? Okay, and good, right. So each time you divide, you should get 1.5, right? So the final proof would be S, 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 right? All three sides are similar. Okay, good. All right, let's look at one more on this page, and then we're gonna go to the next page. So everyone please look at number 11. Okay. So the other ones, they'd be similar, right? You just gotta find the scale factor. Number 11 is a little bit different, okay? So here, we have a shared angle, right? Let's go to Tori. Where do you see the shared angle? At the top, good. So right here, right, both the small triangle and the big triangle use this corner, okay? Good. So now we have one angle. Are there any other ones? Right? Can we prove that the other angle pairs are the same? The bottom left, these two? Okay, how do you know? Okay, what do the arrows mean? They mean, yeah, good. Okay. So the arrows, those mean that these lines are parallel. Okay. And when you have parallel lines and you have a transversal, right? What does that mean about this angle and this angle? Right? They have to be the same. Okay. So these two have to be the same. And actually these two also have to be the same. Okay. So that means you can prove that these triangles are similar. Okay. So if you ever see a triangle where these are parallel at the bottom or parallel, they have parallel sides like that, you automatically know they're similar. Okay. It's like if this one, if it had the parallel marks, right? You wouldn't even have to deal with all the numbers. You just automatically know they're similar. Okay. Obviously, for number 12, it doesn't come with the marks, so you can't cheat, right? You actually have to prove that they're the same. But if they did, you can just skip all that. Right? Okay, everyone please turn to the next page. We're looking at this one now. All right, Jane, you with me? Next page. Okay. So now we're gonna use similar triangles to do something a little bit different. So this time, we're not gonna prove anything, okay? These ones are already told, they already tell us that they're similar, okay? All we're trying to do now is just find the missing side, okay? So, you know that this and this are similar, this and this are similar, okay? So how would you find the missing side? Right, so you gotta find 24 over 16, right? Because that gives you what? Gives you 1.5. And what does that 1.5 mean? What is that 1.5? Yeah, good. So 1.5 is your scale factor. Okay? It's how much bigger the triangle is getting, right? 1.5 times bigger. Okay? Or if you're looking at it backwards, right, it's getting 1.5 times smaller. Okay? So, how do you find x? So we know our scale factor now, it's 1.5. How do you find x? How do you find x? Okay. So you're going to divide 21 divided by 1.5. Okay? You get 14. Okay? So, one thing, you should always double check your answer. Okay? So the way you double check, once you get a number here, then you try, right? Does 21 over 14 actually give you the same scale factor, right? Does it actually give you 1.5? Okay? Go ahead and double check real quick. Does that actually work? Does it work? Okay, good. So if it gives you 1.5, that means it's good, right? So make sure you always double check because it only takes a few more seconds, right? So definitely make sure you double check. All right, so for the remainder of class, you have about 10 minutes. Go ahead and work on these last 3 questions, okay? So the very last one, it's missing a number. Right now, you can't solve it, okay? So please add, let's see, I think it was 19.5. So for the very last question, please add this onto it, okay? That way you'll be able to solve it, okay? Go ahead and solve for those missing sides using the scale factor, okay? And if you finish by the end of class, I'll collect it. If not, that'll be your homework for today. I can just try. Which one? Add that missing one. Right. Today I'm saying Right now, as you can see, 75. How can we turn this shit? Or this. Okay. Now the question where here. 14. Let's try to redraw this. We turn this here, right? 75 on the side. Okay. So this corner. This corner. Turning it this. That's XY. This side. You were saying before, you were saying 14. Where does it go? Okay. So you gotta try